So the following example says that we have magnesium nitrate reacting with ammonium hydroxide, and I've completed the reaction here, and our solid is magnesium hydroxide. And based on the KSP table from above, magnesium hydroxide has a KSP of 5.6 times 10 to the negative 12. So I've also put that into my equation here, and I have both the volumes and concentrations of each aqueous solution. And this question is asking, will a precipitate form? So the first thing I'm going to do is, taking a look at my solid, I need to see the concentration of my magnesium ions and my hydroxide ions. So the magnesium ion concentration can be obtained from the first reactant. The first thing I need to do is solve for the moles. So I know that there is 750 liters, and I multiply it by my concentration. And that will give me 3.00 times 10 to the negative 3 moles. And same thing for the moles of my hydroxide. Okay, so I will do 0.300 liters times 2.00 times 10 to the negative 2 moles per liter. And that will give me 6.00 times 10 to the negative 3 moles. Now that I've gotten the moles, the mole amount for each of my ions that will form a solid, I will now find the concentration for each. Okay, because when we're looking at KSP, we're interested in the concentration of the ions, not the moles. So for magnesium, I have 3.00 times 10 to the negative 3 moles of magnesium, and my new volume is going to be the sum of the volumes of my reactants. So 0.750 liters plus 0.300 liters is 1.05 liters, and that is 2.857 times 10 to the negative 3 moles per liter. Going to do the same thing for my hydroxide. So mole amount divided by the new volume, 1.05 liters, and I get 5.714 times 10 to the negative 3 moles per liter. Okay, if we look at our KSP expression, or equilibrium expression, we're dealing with magnesium hydroxide, this solid that is in equilibrium with its ions. Okay. So I know that the concentration of magnesium and the concentration of hydroxide are calculated here. And the KSP, we're not looking for KSP, but we are solving for our Q value. So we're looking to see where the system is. And we have magnesium concentration times the concentration of hydroxide raised to the power of 2. Remember, because you are taking your concentration of that ion and raising it to the power of the coefficient. So magnesium is 2.857 times 10 to the negative 3 times 5.714 times 10 to the negative 3 to the power of 2. and you should get 9.32 times 10 to the negative 8. And this is your Q value. So this is where your system lies. Q is 9.32 times 10 to the negative 8. KSP from your table is 5.6 times 10 to the negative 12. So we can say that Q is greater than KSP. And if we take a look at the above chart, if Q is greater than KSP, a precipitate is formed. And that's because if Q is greater than KSP, we know that the products are preferred. And because there are more products, there will be a shift towards the left of your reaction. So it will shift to the left to balance out, to reach equilibrium, and therefore a solid precipitate will be formed. The system prefers the products, therefore there is a shift to the left and a precipitate is formed.